Hi everyone, I am Priyavashni, Assistant Professor, Department of Computer Science at Dr. SNS College of Arts and Science, Coimbatore. Today we are going to discuss about the augmented reality focusing on one of the most exciting topics, that is an AR components. In this session we will learn how augmented reality systems actually work, how they are generate digital scenes, how they track user movements, how they display virtual content, and how everything comes together to create a magical immersive AR experience. So let's begin our exploration of AR components. The AR components overview. Let's start with a small overview. AR components are the core systems that enable augmented reality functionality. So we can think of them as the building block of any AR system. There are five key components: scene generator, tracking system, monitoring system, display, and game scene. So all these works together to deliver immersive and realistic AR experiences, combining both real world and then virtual world information seamlessly. So the third is a scene generator, right? The scene generator is the heart of AR system. It is the software or hardware responsible for creating the virtual 3D models, animations, and other digital content that appear over the real world view. So you can think of the scene generator as the artist in the AR setup. Just like an artist paints a beautiful image, the scene generator paints virtual object into our surroundings. So technically it possesses the real world data and generate the realistic digital values in a real time. It takes care of lighting adjustment, shadow effects, and spatial mapping to make the digital objects look naturally blended with the environment. The good example is Unity 3D engine, one of the most popular tools used to build AR applications. For instance, the IKEA Place app uses the Unity to let users place virtual furniture in their living rooms. So to see how it would look before they buy it. So this scene generator ensures that the virtual content we see feel natural and believable. So the fourth is an tracking system. So next we have the tracking system. This component is responsible for understanding where the users is and how where the users is and how they are moving in the real world, so that the virtual objects can be perfectly aligned with the surroundings. Without tracking, virtual content would just float randomly and wouldn't match the real world view. The tracking system uses different sensors like cameras, gyroscopes, and accelerometers to capture the user's position and orientation. There are two main types of tracking systems. They are marker based tracking and the other is a markless based tracking. Okay, the marker based tracking uses the QR codes or image markers as reference point. When the camera recognizes a marker, it displays the virtual object exactly at the spot. The second is a markless tracking, uses the SLAM. SLAM is a simultaneously localization and mapping. So SLAM continuously maps the environment and tracks the device's movement in the real time. No marker is required. For example, Google AR Core on Android devices uses the markless tracking. It detects planes, walls, and light to accuracy place a digital object in your surrounding. In simple words, the tracking system ensures that your virtual objects stick to the real world even when you move. So next is a monitoring system. Moving on to the monitoring system, this component keeps an eye on the user's action and environmental changes to make sure everything runs smoothly. So it involves gaze tracking, that means tracking where the user is looking. Next, gesture recognition means understanding the hand movements or other physical gestures. Environmental sensing, detecting the lighting obstacles or objects in this scene. So all these help in creating interactive and adaptive AR experiences. A good example is the Microsoft HoloLens 2, which use eye tracking to adjust focus and respond to where the user is looking. So if you turn your head or look at a different object, AR system instantly updates to maintain the accuracy and realism. So the monitoring system ensures that the user interaction feels natural, smoothing and initiative, just like dealing with real world objects. The other is display. So now let's talk about the display. This is the hardware that presents a virtual content on to the user's eye. A good display must be lightweight, high resolution and responsive to users' movements. There are different types of AR displays have head mounted display, that is in HMDs, like a HoloLens and Magic Leap. Then next is a smartphone screens, projection displays. For example, Magic Leap 2 uses a waveguide display that shows a sharp, colorful virtual images while allowing you to still see the real world around you. So we can imagine the display is what connects your eyes to the augmented layer of digital informations. Next is the game scene. The final component is the game scene. This refers to the virtual environment or interactive world designed especially for AR gaming and entertainment. The game scene combines all other components, the scene generator, tracking, and display, to deliver the real time, immersive gameplay. A great example is Minecraft Earth, where players can build and explore digital structures in real world locations using AR. AR games like this blend physical movement and digital creativity, giving users a truly interactive experiences. Next is the conclusions. So the AR devices overview, we see these. So next video we can see the AR devices overview. Okay, so the conclusion is, let's quickly recap what we learned in this session. We explored the five core components of an AR system. First is a scene generator that creates a virtual 3D content, and then second is a tracking system, aligns the digital and the real world views. Monitoring systems observe the user behavior and environment, and then as a display presents the virtual visuals, and then is a game scene, brings it all together for interactive experiences. So each of these components plays a vital role in making augmented reality work smoothly and naturally. So we can see the AR components from the foundations and powers every AR experiences, whether it's a gaming, education, healthcare, medical visualizations. So in this next part of this series we will move on to the AR devices, so where we learn about the different hardware technologies that brings these AR experiences to the life. So thank you.